Hi, ma'am. This is T. Kushi, and my roll number is 37. Uh, my topic for concept video for the data structure subject is compare selection sort versus insertion sort. So let us know what is selection sort. Selection sort is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest element from the unsorted portion of the list and moving it to the sorted portion of the list. The algorithm repeatedly selects the smallest element from the unsorted portion of the list and swaps it with the first element of the unsorted portion. This process is repeated for the remaining unsorted portion of the list until the entire list is sorted. One variation of selection sort is called bidirectional selection sort that goes through the list of elements by alternating between the smallest and largest element. This way, the algorithm can be faster in some cases. Sorted part is placed at the left, while the unsorted part is placed at the right. In selection sort, the first small element is selected from the unsorted array and placed at the first position. After that, second smallest element is selected and placed in the second position. This process continues until the array is entirely sorted. So the algorithm mainly contains two subarrays, the subarray which is already sorted and the remaining subarray which is unsorted. After every iteration, sorted subarray size increases by 1, whereas unsorted subarray size decreases by 1. So after n iterations, we will get the sorted array. Here, n is nothing but the size of the array. So let us see the working of selection sort. Set the first element as minimum. So the first step is to set the first element as minimum. In step 2, you're going to compare minimum with the second element. If the second element is smaller, then minimum assigned to the second element. Compare minimum with the third element. Again, if the third element is smaller, then assign the minimum value to the third element. Otherwise, do nothing. So this process goes on until the last element. So after each iteration, minimum is placed in the front of the unsorted list. So for each iteration, indexing starts from the first unsorted element. So step 1 to step 3 are repeated until all the elements are placed at their correct positions. So here you can see the example. We are going to take an array which is consisting of 4 elements. So the size of array is 4, n is 4. So you're going to get the sorted array in 4 steps. So the array is consisting elements called 7, 5, 4 and 2. First minimum element is 2. So this minimum element 2 is placed from unsorted array to the sorted array. In the second step, the minimum element is 4. So 4 is placed to the sorted array. Next it is 5. Next it comes 7. So at the end, you will have empty unsorted array and filled sorted array. So as already mentioned, the unsorted array size decreases, whereas the sorted array size increases as the iteration goes on. So in 4 steps, you will get the sorted array using selection sort. So here in this slide, you can see the selection sort algorithm as well as the program. So let us go through the program. So you're going to define a class, you're going to create a definition class or def sort of nums. So nums is nothing but the name of the array for I in range of 5. That means in that array, you're going to have 5 elements. Min position is equal to I for j in range of I, 6. If num of j is less than num of min position, then min position becomes j. So min position is equal to j and temp is equal to num of I. Num of I is equal to num of min position. Num of min position is equal to temp. So we are going to define the array as 5, 3, 8, 6, 7, 2. And we are going to call the function sort nums and you're going to print the output. So as you can see in the output, you're getting the sorted array that is 2, 3, 5, 6, 7, and 8. So hope you understood the selection sorting algorithm as well as the program. Now we'll look into the advantages of selection sort algorithm. So the main advantage is that it is very simple and easy to understand and preserves the relative order of items with equal keys, which means it is stable, works well with small data sets, and it is adaptable to various types of data types. Selection sort is an in-place sorting algorithm which means it does not require any additional memory to sort the list. So it is in-place sorting algorithm. So whatever place is available, it will only use that space and it does not require any extra space. So there will be no extra memory required, no memory wastage is also done. So now let us look at the disadvantages of selection sort algorithm. Selection sort has a time complexity of big O of n square in its worst case and best case and average case. So this is one of the main disadvantage, and it does not work well on large data sets. Selection sort algorithm needs to iterate over the list of multiple times. Thus, it can lead to an unbalanced branch, and it is time taking because particular list, you have to go through that list many times, multiple times. So it is time taking as well. Selection sort has a poor cache performance and hence it is not cache friendly. As you know, cache is nothing but the fastest memory storage thing. So it is not cache friendly. So it is one of the main disadvantage of selection sort algorithm. So now let us look into the insertion sort. Insertion sort works similarly to the sorting of playing cards in hands. It is assumed that the first card is already sorted in the card game, and then we select an unsorted card. If the selected unsorted card is greater than the first card, it will be placed at the right side. Otherwise, it will be placed at the left side. So similarly, all unsorted cards are taken and put in their exact places. The same approach is applied in the insertion sort. The idea behind the insertion sort is that the first take one element, iterate it through the sorted array. All that is simple to use. It is not appropriate for large data sets as its time complexity for average and worst cases big O of n square, where n is the number of items. Insertion sort is less efficient than the other sorting algorithms like heap sort or quick sort or merge sort, etc. So let us see the working of insertion sort. The first element in the array is assumed to be sorted. Take the second element and store it separately in a key. Compare the key with the first element. If the first element is greater than key, then key is placed in the front of the first element, or else it is placed at the back side of the first element. Now the first two elements are sorted. Take the third element and compare it with the elements on the left of it. Place it just behind the element smaller than it. If there is no element smaller than it, then place it at the beginning of the array. Similarly, place every unsorted element as its correct position. So what you understand is when an array of elements are given, take a particular element and assume that to be sorted, and remaining elements are stored in the value of key. So this key element is compared to the element which you have taken as sorted element. So if the key element is less than the sorted element, it is placed towards the left side. If it is greater, it is placed towards the right side. So this is the main theme of insertion sort. So let us look at the example. So here we are going to take an array of 7, 4, 5, 2, and you are going to take 7 as a sorted element. So no element on the left side of 7, so no change in its position. Now let us start comparing. So as 7 is less than 4, therefore 7 will be moved forward and 4 will be moved to 7's positions. In the same way, as 7 is greater than 5, 7 will be moved forward, but 4 is less than 5, so there will be no change in the position. And 5 will be moved to the position of 7. So as all the elements on the left side of 2 are greater than 2, so all the elements will be moved forward and 2 will be shifted to the position of 4. In this way, after all these arrangements, you will get the sorted array as 2, 4, 5, and 7. So here in this slide, you can see the insertion sort algorithm as well as the program. So let us go through the program. L, you're going to take an empty list. N is number of elements. And using for loop, you're going to append the elements into that particular list. And for I in range of length of L, for j in range of 0, I, if L of I is less than L of j, then temp is equal to L of I is equal to L of j, and L of j is equal to temp. And you're going to print the sorted list. So as you can see in the output box, you're going to enter the number of elements as 6. You're going to give the input of the list, and you're going to get the sorted list as shown. So now let us look at the advantages and disadvantages of insertion sort. So coming to the advantages, the main advantage of insertion sort is that it is simple. It exhibits a good performance when dealing with a small list. The insertion sort is an in-place sorting algorithm, so the space requirement is minimal. Coming to the disadvantages, the disadvantage of the insertion sort is that it does not perform as well as the other sorting algorithms with n squared steps required for every n element to be sorted, the insertion sort does not deal with a large list. The insertion sort is particularly useful only when sorting a list of few items. So now let us look at the difference between insertion sort and selection sort. So insertion sort is a simple sorting algorithm that builds the final sorted list by transferring one element at a time. Whereas selection sort, in contrast, is a simple sorting algorithm that repeatedly searches remaining items to find the smallest element and moves it to the correct location. So let us know the time complexities and space complexities of selection sort and insertion sort. For selection sort, the time complexity in best case, average case, and worst case, it is big O of n square, and space complexity is big O of 1. And for insertion sort, best case is big O of n, and average case and worst case is big O of n square, and space complexity is big O of 1. And the main difference is also observed in its functionality, efficiency, and complexity. So coming to functionality, insertion sort transfers an element at a time to the partially sorted array, while selection sort finds the smallest element and moves it accordingly. Coming to the efficiency, another difference between insertion sort and selection sort is that the insertion sort is efficient than selection sort. Coming to complexity, complexity is also a difference between insertion sort and selection sort. Insertion sort is more complex than selection sort, and insertion sort is efficient than selection sort. So here are the differences between insertion sort and selection sort. Insertion sort is simple sorting algorithm that builds the final sorted list by transferring one element at a time, whereas a selection sort algorithm repeatedly searches the remaining items to find the smallest element and moves it to the correct location. Insertion sort transfers an element at a time to the partially sorted array, whereas selection sort finds the least element and moves it accordingly. Whereas insertion sort is more efficient when compared to the selection sort, and selection sort is less efficient, and insertion sort is more complex whereas selection sort is simpler. So some of the basic comparisons are that coming to its nature, insertion sort is very stable, whereas selection sort is unstable. Coming to the process that is to be followed, in insertion sort, elements are known beforehand while location to the place them is searched, whereas in selection sort, location is previously known while elements are searched. Coming to immediate data, insertion sort is live sorting technique which can deal with immediate data, whereas selection sort cannot deal with immediate data. It needs to be present at the beginning. Coming to the complexities of best case, for insertion sort, it is big O of n, and for selection sort, it is big O of n square. And coming to the basic difference, the data in the insertion sort is sorted by inserting the data into an existing sorted file, whereas the data in selection sort is sorted by selecting and placing the consecutive elements in the sorted locations. So these are some of the major differences. So coming to the conclusion, insertion sort and selection sort are two sorting algorithms. Both are suitable for sorting a smallest data set. The main difference between insertion sort and selection sort is that insertion sort performs sorting by exchanging an element at a time with a partially sorted array, while selection sort performs sorting by selecting the smallest element from the remaining elements and by exchanging it with the element in the correct location. So coming to its time complexities, time complexity of selection sort is always n into n minus 1 by 2, whereas insertion sort has better time complexity as its worst complexity is n into n minus 1 by 2. So generally it will take lesser time or lesser comparisons. So we conclude that generally both of them are same. Both of them are applicable only for small lists or or for small data sets. They are not applicable for large data sets. And comparing with other sorting techniques, both of them are less efficient. But when you compare sorting algorithm and insertion algorithm or insertion sorting is a bit more efficient when compared to sorting algorithm, and insertion algorithm is a bit more complex, whereas selection sort is a bit simpler. So what is the main difference is that in selection sort, you are going to check the element each and every time. You have to traverse through the entire array, whereas in insertion sorting techniques, you are going to assume a particular element to be sorted, and you are going to compare that element with each and every key element. So if the key element is less than the assumed element, then it is placed towards the left side. If it is greater, it is placed to the right side. So in this way, you're going to get the sorted array. So this is the main difference. And coming to the time complexities for selection sort, in all the cases, the time complexity in best case, worst case, average case, it is big of n square, and space complexity is big of 1. Whereas for insertion sort, the time complexity for the best case is big of n, and for worst case and average case, it is big of n square, and its space complexity is big of 1. So you can also conclude another point that the space complexity for both insertion sort and selection sort is big of 1, and the time complexity in average case and worst case is same for both the selection sort and insertion sort. It is nothing but big of n square. So these are the main differences. And the other difference is that selection sort is, as you can see here, selection sort is unstable, whereas insertion sort is stable. And coming to immediate data, uh, insertion sort can accept the immediate data also, whereas the selection sort cannot accept the immediate data. So these are some of the main important differences between selection sort and insertion sort. Hope you guys understood it. Thank you so much.